Welcome to the radical function unit. For 3a, we're just going to be simplifying radicals. So to simplify radicals, there's two ways of doing it. You can do what's perfect squares, memorize your perfect squares. So you memorize what 2 squared is, 4, you go 3 squared, you remember 9, 4 squared, 16, 5 squared, 25, 6 squared, 36, 7 squared, 49, 8 squared, 64, and we're going to keep on going, 9 squared, 8, sorry, that should be an 81, 10 squared, 100, 11 squared, 121, 12 squared, 144. You can memorize further. Really, the ones you have to memorize or you should know are 2 through 10, definitely. So we're going to look at so that's one way method, by memorizing these is one method of simplifying radicals. So to do that, like in example 1 here, simplifying the square root of 50. That can be broke down. That's not in the simplest form. So you think, which one of these perfect squares, what's the biggest perfect square that would divide into 50 evenly? So 50 divided by what number here would divide in evenly? And it'd be 25. So you could break this into the square root of 25 and 2. And the square root of 25 is 5. So you get your answer 5 square root of 2, and that's simplified. So we could do it that way. So you're thinking about your perfect squares. That's usually the fastest way. Or another way we could do this is to maybe break it down with factoring trees. So put 2 numbers, multiply to 50. So you can do any 2 numbers. And I always circle my prime numbers, so 5. 10 breaks down into 2 and 5. So both 2 and 5 are prime numbers. And then I look for, since it is a square root, this is a square root. Square root is, like there's a 2 here, square. You're looking for pairs. So that I have a pair of 5s, they're my prime numbers. And so that will come out, every pair there then comes out of the radical, outside of the radical. And what does not have a pair stays inside. Whatever's left or whatever's on the outside or inside, you would multiply. So you could do it either way. So moving on. We're going to simplify the square root of 72, x to the third, y to the fifth. So 72, I think about what's the biggest perfect square that divides into 72? And that is 36 and 2. Square root of 36 is 6, so that's the biggest. And then with the variables, since it is a square root, we're looking at how many squares can you divide out of 3, and there's 1. We'll do that in the next step. And then how many squares can you divide out of the fifth, and there's 2 of them. But again, we'll do that in our next step. So the square root of 36 is 6. And then the 2 is going to stay underneath, stay inside the square root, because we cannot simplify that any further. You can't break down a square root of 2. Square root of x to the third, you can take one pair, or square, you can divide 3 by 2 once, so there's x to the first outside. How many y to the fifths can you divide out of a square? And there's 2 of them. And then what's left is 2, 1x, and 1y. So that's doing it with perfect squares. If I do the same problem with trees, so if I do the same problem with trees, I would do 72. It doesn't matter which 2 numbers you choose, 9 and 8. It could be 36 and 2. And we keep breaking these down, 3 and 3. Those are your prime numbers there. 8, 2 and 4. 4 can be broke down in prime numbers, 2 and 2. And then, so we're looking for pairs. So if I'm looking at pairs, I'm looking at, because it's a square root, 3's come out, or a pair of 3's, and a pair of 2's. Doesn't matter which ones you circle. So that would go on the outside, so we'd have 3 times 2 on the outside from the pairs. And on the inside would have a 2 would be on the inside. Now, looking at your x's, there are 3 x's. And you need square root, so pair of x's comes out. So that'll come on the outside. There's an x left over here, so that's on the inside. For the y's, we have 5 y's. And how many pairs of y's? We got 1 pair and 2 pairs. So 2 pairs of y's, y times y is y squared. And then there's a y left over, so that stays underneath the radical. So if I multiply this out, 3 times 2 is 6, x, sorry, that should be x, y squared. Square root of 2xy. So either way, you get the same answer. Moving on. I'm not going to continue to do, so actually, this is cube root, so here you'd have to memorize perfect cubes. So 2 to the third, 8, 3 to the third, 27, 4 to the third, 64, and maybe up to 5 to the third, 125. That's about as big as you really need. So what's the biggest perfect square that divides into 72, or a perfect cube that divides into 72? And that's 8. So here we would have cube root of 8 and 9, so 8 times 9, x to the third, y to the fifth. And we have cube root of 8 is 2. Cube root of x to the third, so now it's a cube root, so we need 3 of a kind, so there's 3 x's. So an x is going to come out from that. Cube root of x to the third is x. And then there's y to the fifth. How many cube roots can you divide out of y to the fifth? Well, you can divide just one group out of that. And what's left over is a 9y squared. So you can also do this with the trees, break it down, and now you just would need 3 of a kind instead of 2 for the first square root. Last problem, we have 4th root. Now 384 is pretty big, so I'm not going to try to memorize what the biggest perfect square will go in there. You could use your calculator. Since I don't have a calculator on me, I'm just going to do, just breaking it down. So 2 times 192, 2 is the perfect square. 192 is an even number, so it'll be broke down into 2 and 96. And 96 is 2 and 48. 48 is 2 and 24. 24, 2. I just continue with the 2's. It's easy. Easy to divide something by 2. Easier than anything else. 2 times 6. And 6 is 2 times 3. So we're looking at a 4th root. So that means we need 4 of a kind. So 4 of a kind, so 1, 2, 3, 4 2's. So that's going to be a 2 that comes out from that. Another, nope, no more there. So that's only 3 2's. I need 4, so that doesn't work. Before I move on and drawing the 4th root, how many x to the fifths can you divide out of with a 4th root? And that's just 1x. Y to the 18th, how many can you divide out? That's 4 of them, so y to the 4th. And z to the 0. Well, anything to the 0 is 1. But you can't divide anything out, so that just doesn't do anything. It goes away. What we do now is draw your 4th root. Make sure do not forget the little index 4. And that's a 4. So we have 2 times 2 times 2 times 3, so that's 8 and 24 left on the inside. And we have an x left over. And there were 16 y's used up with the fourth root to get to y to the fourth. So there's 2 more y's left over. And that's your final answer. Please come to class with questions. And thank you.